So let's talk about something I think is absolutely fascinating. And if you're building with AI, it's critical. How do we keep our powerful AI agents performing at their peak, especially when we give them these really long, complex jobs to do? Well, the answer lies in a field called context engineering.
All right, so here's a quick look at what we're going to cover. We'll start with what I call the agent's paradox, then dive into the solution, the art of context engineering. We'll break down 3 core strategies, look at a really smart design called a layered action space, and wrap up with something called the bitter lesson for AI.
First up, the agent's paradox. Here's the core of the problem. What makes AI agents so powerful is that they can run on their own, right? They can just call tools over and over again to solve problems. But that very thing, that ability to work for a long time, well, it turns out it's also their biggest weakness. And that leads us to this really important question. Why is it that these super powerful AI agents seem to get, for lack of a better word, dumber the longer they work on a task? It feels totally backward, but I'm sure if you've ever tried to build one of these agents, you've seen this exact thing happen. And look, this isn't just a theoretical thing. For a real popular coding agent like Manus, a single, typical task can involve about 50 different tool calls. Now just try to imagine all the data, all the outputs from every single one of those calls, just getting piled into its working memory. It gets messy, and it gets messy fast. This problem actually has a name. It's called context rot. It's a great term. Basically, as the agent's short-term memory, its context window gets more and more cluttered, its performance just starts to fall off a cliff. Its attention budget gets totally spent, and that's when you see it start to make mistakes, repeat itself, or just get confused.
Okay, so that's the problem. How in the world do we fix it? Well, this is where a new discipline comes in, specifically designed to fight context rot. And that's what we call the art of context engineering. It is all about being super intentional about what information the agent sees at any given moment.
And you know who put it perfectly? Andrej Karpathy. He said, context engineering is the delicate art and science of filling the context window with just the right information for the next step. You see, the goal isn't just to stuff more information in there, it's about putting the exact right piece of information in at the exact right time.
So how do we actually do this? What's really cool is that this whole field can pretty much be boiled down into 3 main strategies. And you see these everywhere in almost any production-grade agent system. They are reduce, offload, and isolate. So yeah, these 3 are your new toolkit. First, you reduce the info to make it smaller. If that's not enough, you offload the really big stuff out of the way completely. And for special cases, you can isolate a task with its own little sub-agent. So let's kick things off with reduce.
This slide just shows it perfectly. This is the reduce strategy in a nutshell. On the left, you've got the full, raw data, like a huge snippet from a web search. It's super heavy on tokens. But on the right, you have the compact version, just a tiny little reference like a file path that points to where the big file is. It's so much cleaner and more efficient.
But the real key is knowing when to do this. It's usually a 2-step dance. So as the context starts to get full, let's say it's approaching 128,000 tokens, the system kicks into compaction mode. It reversibly shrinks the oldest stuff into those file paths. But if that's still not enough, it escalates to summarization, where it irreversibly creates a summary just to save the most important bits.
And that leaves us right into our second strategy, offload. The idea here is really simple. You just save the big clunky tool results to an external file system. The agent's main memory just keeps that tiny little file path. But, and this is key, it can always go and grab the full data whenever it needs it. And what's really interesting is that a lot of the top systems use simple, old-school command line tools like glob and grep for this, because they're just so fast and simple.
All right, our third strategy is isolate. And this one is just so clever. It's all about smart delegation. So you start with a main planner agent that's kind of overseeing the whole operation. And then, when a very specific self-contained job comes up, it delegates that task to a dedicated executor agent.
And here is the magic trick. That new executor agent gets its very own, brand new, totally clean context window. This means there's zero pollution from the main task, and this little sub-agent can focus with absolute clarity on doing its one job perfectly.
Now, these strategies are fantastic for managing context once it's already there. But what if we could design the whole system to stop the context from getting bloated in the first place? And this brings us to a really beautiful architectural concept called a layered action space.
You know, when you first start building an agent, your gut instinct is to just give it hundreds of tools, one for every possible thing it might need to do. But this is actually a huge trap. Every single tool description eats up your precious context tokens. Giving the model too many choices can actually confuse it, and trying to fetch tools on the fly can just interrupt the agent's entire flow.
So, check out this brilliant solution from Manus. At the very top layer, you have a tiny, minimal set of function calls, less than 20 of them. These are your absolute basics, like a shell tool or a text editor. The next layer down, you've got sandbox utilities. These are pre-installed commands that the agent uses through that shell tool. And finally, at the bottom layer, you have packages and APIs, where the agent can actually write and run its own Python scripts. The beauty of this is the model only needs to know about that tiny set of tools at the top, but that simple toolkit unlocks this massive world of capabilities. It's just elegant.
Okay, let's zoom out for a second. These techniques are amazing, but they all point to something much deeper, a bigger philosophy about how we should build AI systems that are meant to last. It's famously known as the bitter lesson for AI, and it's all about building for the models of tomorrow, not just the ones we have today.
So what does this actually look like in practice? Well, here are the big takeaways. First, you have to design for evolution. Your system should get smarter all by itself, just by you swapping in a better base model. Second, stay unopinionated. Simple, flexible designs are always going to adapt faster than complex, rigid ones. And finally, a really important one. Remember that sub-agents are tools, not a team. You should use them for the technical benefit of isolating context, not because you're trying to copy a human organizational chart.
And this quote from OpenAI's Hyung-Wong Chang just says it all. Add structures needed, remove them later because these shortcuts will bottleneck further improvement. And that right there, that's the bitter part of the lesson. The clever little workarounds you build to help today's model might be the very thing that holds back a much smarter model in the future.
So I'll leave you with one last question to really think about with your own projects. Is the architecture you're building today helping your AI now, but actually crippling its potential for tomorrow?